Hello students, today we are going to start off with this new chapter which is sources of energy. So now, since this chapter is a bit theoretical in nature, so we have prepared some notes and you can pause this slide anytime and you can copy the notes down. Alright, let's start. First of all, if we are trying to find source of energy, that means if you are talking about fuel, what should be the key characteristic of a fuel? See, fuel should have a high energy output per unit burn. So per unit mass or volume. So whatever fuel we are using or combusting, it must give us very good amount of heat or the energy. It should be easily available. It should not be very hard to access in remote areas. It should be easy to store and transport. That means it should not be very dangerous to health. For example, if we know that petrol and diesel, they are very highly available fuel these days. Obviously we are using it since our childhood in our cars, petrol, bikes, everywhere. Now it is dangerous to store petrol at home and at different places because it is highly combustible substance, but that does not mean that we stop using that fuel just because it is highly combustible. So we have to take safety precautions as well, but yes, this point said it should be easy to store and transport because petrol and diesel can be easily transported from one part of a country to another via oil tankers. It should be economical. Now I won't say anything on this concern because yes, fuel is getting expensive, but the key property of a good fuel is that that fuel should be economical. Okay, now what are sources of energy? There are two main sources of energy which are called conventional and non-conventional sources of energy. Conventional word directly means that the energy which is present on the surface, inside the surface of earth basically, or on the surface of earth as well, because groundwater and the surface water is also considered inside the category of the conventional sources. So conventional sources are basically non-renewable sources of energy because once they get depleted or once they are completely exhausted, we don't have any other method to replenish them. So they are called conventional sources of energy, and then there are non-conventional sources of energy which are considered as those part of energy or those sources of energy which we can harness indirectly, not but directly, because we have to do some techniques and other stuff and we have to get the energy harnessed out of it. Okay, so this is conventional and non-conventional sources of energy. So the conventional sources are like flowing water, fossil fuels, coal, petroleum, natural gas, whereas non-conventional are solar energy, wind energy, biomass, ocean energy, tidal. This ocean energy itself contains tidal energy, wave energy and ocean thermal energy. Okay, we are going to discuss all these types of energy. Then we have geothermal energy, nuclear energy, etc. Some sources of energy are renewable like sun, wind, flowing water, ocean, wood, biomass. Out of these all, some sources of energy are renewable, that means they can be used again and again. For example, if we make or build a machinery to harness energy of wind, that means we are talking about windmill. Alright, so we have to convert wind energy into electricity and we are doing it because we have already structured everything, we have already planted a windmill there. Now every time wind will blow, we are going to get energy. So this side of energy can be harnessed again and again. But non-renewable sources of energy are those sources of energy which once gets completed, once we are done with that, we do not have any method to replenish them. That means it is completely over, out of stock. So some source of energy are non-renewable like coal, petroleum and natural gas. Now we know that, see, we are using the crude oil, you know, diesel, petrol, kerosene, they are all made of crude oil only. Crude oil is actually, you know, simple distillation. So what is simple distillation? We just differentiate various components present in a mixture via a very simple process. Similarly, there is a fractional distillation. Fractional distillation is more complicated process, but it is done for substances like crude oil, and crude oil gives us then what? Petrol, diesel, etc. Now crude oil has been in use for people on earth for so many years. Not even, I won't even talk about First World War, even before that crude oil was in use, and since then till now, even till the time you are watching this lecture, the crude oil is being exploited all over the world. So one day crude oil is going to be finished. And that is why we have termed the components of crude oil into non-renewable sources of energy. Now, the conventional sources of energy, we are moving on to it. First of all, we are talking about fossil fuels. Let me tell you what fossil fuels are. All the biomass contains what? It contains human beings, animals, plants, anything which has biological nature. So not stones, not the sand, silt, silica, not like this substance which has biomolecular mass, okay, biomolecular formation. So all the biomass, if by some method or by some happening in the nature, it gets accumulated in one place and it gets submerged under water bed, under land bed or under sea bed, it will start decomposing. And once the biomass gets decomposed over a very long period of time under particular set of pressure and temperature, that get converted into fossil fuel. So coal is a fossil fuel, petrol and diesel, basically we are talking about crude oil only. Both coal and crude oil is fossil fuel. So for formation of coal, the solidification takes place under different set of pressure and temperature, whereas the formation of crude oil again takes different set of pressure and temperature. So let's see what we have written. Fossil fuels are fuels formed inside the earth from the remains of plants and animals. We are talking about biomass here, after millions of years. So the time span of decomposition and getting them converted into something which we are using right now is not a story of like 1, 200 or 2000 years. It's taking place in million of years. And that is why once we use the entire stock, it will take many more million of years to again rebuild it. And that is why we are terming it as a non-renewable sources of energy. The fossil fuels are coal, petroleum and natural gas. Fossil fuels are all non-renewable sources of energy, so they should be considered and used judiciously. Obviously, we have to think twice before using them abruptly, right? Now, what are the disadvantages of fossil fuels? Though fossil fuels are available and we are using it, but there must be some disadvantages. First of all, we know that pollution. They produce a lot of pollution. So let's start. Burning of fossil fuels release gases and harmful particles which cause air pollution, and not just air pollution, they are causing these particulate matter which is getting suspended in our atmosphere due to burning of fossil fuels. Is not just causing the air pollution, it is causing land pollution, air pollution and every other pollution, because the whole this geographical aspect of our earth is interconnected. If we mess up with one thing, we are going to do something wrong with the other thing. Land is connected with water, water is connected with wind, wind is connected with something else. So one pollution can always lead to other. It's like a chain, okay? Now, burning of fossil fuel releases acidic oxides, sulfur oxides, nitric oxides, etc. Oxides of sulfur and nitrogen, which I was naming, sulfuric acid also, nitric acid also, or acid, or in simple terms, oxides of sulfur and nitrogen, which causes acid rain, which is harmful for everyone, not just plants, animals, for entire atmosphere, okay? So this causes acid rain. Have you ever seen an acid rain? It doesn't generally happens, but during acid rain, it's not like that. The name is very dangerous here, acid name. It is not the rain of acid, and the acid is a word which is quite dangerous for students like us who perform little experiments in our labs, because we deal with what? Nitric acid, sulfuric acid, etc. And even nitric acid, if you by chance, by mistake, it gets drop on your skin, it turns it into what? Orangish hard color. Basically it is a protein test for higher classes, but yeah, don't do that ever. So these acids are dangerous. So this term doesn't mean that acid is falling from sky and everything is getting burned. No, the water gets more content of acidic part, that means oxides of sulfur and nitrogen, and that part is very harmful. And then when the rain, whatever oxide which are dissolved into the water through evaporation and everything, and then the rain happening due to all over that part where these oxides are very high in content, there the acidic part, see, I'll tell you a technical term which is called pH value. pH value is basically the value, it's a scale of checking whether a given any soluble material or any solvent is acidic or basic in nature. For example, water has a pH value of 7, it is in the between. So the acidic and basic are varying from number 1 to 14. So these things, when acid rain will happen, the acidic nature of the water will be very high. That is what it means by acidic rain. Now, burning of fossil fuels releases a large amount of carbon dioxide gas, which increases the temperature of the atmosphere. Now, are we talking about global warming, greenhouse effect? Yes, this is exactly that. Now, you should know what is global warming before I move on, because now we are going to talk about a lot of stuff related to carbon dioxide, and it is trapping a lot of heat, etc., etc. So let's discuss what exactly is global warming. You should know. Earth, atmosphere, not the surface. Consider Earth. Okay. Sun, heat waves coming from sun sorry, entering our atmosphere and getting reflected back. Till here it was simple. Now this heat wave which is striking the earth's surface is reflecting back. If it is not allowed to pass from this atmosphere, because lot of things is trapping this heat inside this shaded region, that means in the atmosphere. So the overall temperature of the earth will start increasing gradually, right? This is what global warming is. Global warming is basically the increase in temperature of overall earth due to trapping of sun's heat by some greenhouse particles. For example, carbon is the carbon, methane, CFCs, chlorofluorocarbons, and then all the these gases, lot of gases. For example, ozone, not the exactly ozone we are talking about, a part of oxygen that also is included in this thing. So lot of gases, they take part in the overall heating of the earth's temperature, and that is what we are calling these days as global warming. So yes, we are coming back to the topic. Burning of fossil fuel releases a large amount of carbon dioxide, which is the main component of global warming gas or greenhouse gas. It is actually called as greenhouse gas, which increases the temperature of atmosphere and causes global warming, which is greenhouse effect. Next, there are some of the diagrams which are showing the bad effects of the overall pollution thing or the global warming thing. For example, first of all, in this diagram you will see that there is an industry which is burning a lot of stuff, and it is releasing a lot of acidic particulate matter in the atmosphere. Now this thing gets mixes with the cloud, and what we are increasing, the oxide. So basically it will follow the acid rain. So these gases dissolve in rainwater to form acid rain, and the acid rain kills plant life, it pollutes rivers, streams, and erodes stonework. So it can do a lot of bad effects. The change in color of Taj Mahal is also due to the oxides present near Agra, where because basically a lot of limestone factories are there. So these factories evolve very poisonous gas, and these gases are affecting the color, not just color, because the whole structure of Taj Mahal is actually getting eroded, because the Sangmarmar, it's a very precious stone. So that stone is getting corroded because of the chemical reaction of those gases. So that is why this is also in the picture. Now here we were talking about the global warming effect, which is sun giving us heat waves, the heat waves getting reflected from at surface but being trapped in the atmosphere, because these greenhouse gases like carbon dioxide, methane, they are not letting it out. Okay. Then this is what you have already seen a lot of places, the melting of ice. Melting of ice can produce a lot of bad effects. For example, first of all, melting of ice is not helping in decreasing the temperature of the overall earth. Then when the fresh waters, because you know that 70% of the whole in our system is made up of water, like only 30% land is there and 70% of oceans are there, like the water, right? So out of which a very huge part is in frozen form on the poles, Antarctica and the south one. Now in poles, whatever ice, which is basically the freeze form of water, is there, due to increase in temperature, it is melting. So that is because ice is very pure form of water, right? So that pure form of water is getting mixed with the lime water, a saline water which is in the sea or oceans. Now that mixing is changing the orientation, the direction and the temperature of streams. Which streams? Sea streams or ocean streams, and ocean streams are the factors which control the overall climate of our globe. So now see, due to the increase in temperature, the ratio of salt and fresh water in the oceans is getting affected, due to which the oceanic streams, oceanic currents, they are getting affected, and since they control the climate of throughout the globe, that is getting affected. So see how we are affecting everything which is related to one another.